A warm welcome to our presentation. As part of our course project, we are selecting the topic sentiment analysis. Let me introduce you to my team: Ravi Tejalu, Seema Srinivas, Sureka Hanmantgiri. What is sentiment and emotional analysis? Sentiment or emotional analysis is the process of automatically identifying and characterizing the emotional tone or sentiment expressed in textual data. This technology leverages natural language processing and machine learning techniques to extract insights from large volumes of text data, such as social media posts, customer reviews, or news articles. By analyzing the sentiment or emotions conveyed in text, organizations can gain valuable insights into public opinions, customer feedback, and trends. Sentiment analysis and emotion detection plays a crucial role in improving information retrieval systems as they enable more effective content recommendation, sentiment-based search, and trending analysis, ultimately enhancing decision-making process in various domains including marketing, customer service, and public opinion research. Sentiment analysis, often referred to as opinion mining, is the process of determining the overall sentiment or polarity expressed in a piece of text. It categorizes text into one or more of the following sentiment classes: positive, negative, and neutral. We all know what it is. Positive indicates a favorable or positive sentiment, negative indicates an unfavorable or negative sentiment, neutral indicates a lack of strong sentiment or a sentiment that is not clear. Emotion analysis, also known as affective computing, goes beyond sentiment analysis by identifying the categorizing specific emotions expressed in text. Emotion analysis aims to understand the underlying emotional states of individuals based on their language use. Common emotions that are often analyzed includes happiness, sadness, anger, fear, surprise, and disgust. Rule-based sentiment analysis is one of the techniques that's used in sentiment analysis. Rule-based sentiment analysis uses a set of manually crafted rules to identify sentiment within text. The system scans the text for specified words and phrases associated with positive or negative sentiments and assigns a sentiment score based on the presence of these indicators. The process of rule-based sentiment analysis involves several steps where the system evaluates the text to determine the overall sentiment. And here's a breakdown. Tokenization. The system starts by breaking down the text into smaller pieces called tokens. Tokens can be words, phrases, or even punctuation marks. This process helps the system to analyze the text in chunks that carry semantic value. Part of speech tagging. After tokenization, the system may perform part of speech tagging to identify the grammatical role of each word, such as noun, verb, adjective, etc. This is important because sentiment is often conveyed by adjectives and adverbs. Sentiment lexicon. The system relies on a sentiment lexicon, which is a dictionary-like collection of words and phrases where each entry is associated with a sentiment score. This score typically ranges from negative to positive. For instance, -1 for negative, 0 for neutral, +1 for positive. Rule application. With the text tokenized and tagged, the system then applies the predefined rules to the text. These rules might be simple, like assigning a score based on the presence of positive or negative words, or complex, taking into account the structure of the sentence, negation, and intensity modifiers. Score assignment. Each identified word or phrase that has a sentiment value contributes to an overall score for the text. For example, if the sentence contains 3 positive words and 1 negative word, the positive words would contribute positively to the score, while the negative words would reduce it. Context and modifiers. The system also looks for context, that might alter the sentiment score of words. Negations, for example, not good, can flip the sentiment of a token, while modifiers, very good, can amplify it. Conjunctions can also influence how sentiments are combined. The car is fast but expensive. So, this sentence has negations, it has an amplifying word, and it has a modifier. So on the scores that is assembled to this, each word varies the sentiment score, and that is how it is calculated. Sentiment score aggregation: after all words and phrases have been evaluated, their scores are aggregated to give a final sentiment score for the text. This can be sum of all the scores, an average, or a more complex combination depending on the rules set by the system. Sentiment classification. Finally, the text is classified based on the final sentiment score. If the score is above a certain positive threshold, the text might be classified as positive. If it's below a negative threshold, as negative. And if it's in between, it's tagged as neutral. Let's understand what's tokenization. Tokenization is a fundamental step in most natural language processing tasks, including sentiment analysis. It involves dividing a string of input into smaller units called tokens. Here's a more detailed explanation of this process. What are tokens? Tokens are the building blocks of text. In human language, these could be words or phrases that convey a certain meaning. In the context of computational linguistics and NLP, a token can be a word which is a sequence of characters separated by spaces and punctuation marks like commas, full stops, semicolon, etc. A token can also be a punctuation mark itself, which can have semantic or synthetic value for sentence structure and meaning. Tokens can include numbers, symbols, or other elements depending on the tokenization criteria. How tokenization works. Let's understand how it works. Tokenization works by applying a set of rules to identify where tokens begin and end. These rules can be simple or complex, depending on the language and the application. Here are some examples of the rules. White space tokenization: the most straightforward method where space and line breaks are used to separate tokens. I like apple becomes, we tokenize it into I like apples, where the spaces are removed. Punctuation based tokenization: this approach includes punctuation as separate token. I like apples and a hyphen, where hyphen is also considered as a token. Advanced tokenization: more sophisticated tokenizers may identify contractions such as turning don't into do not, or complex word compounds. Part of speech. Part of speech is a basic grammar application. That is tagging it's just a tagging, the process of labeling each token, typically a word, in text with its appropriate part of speech based on both its definition and its context, that is, its relationship with adjacent and related words in a phrase, sentence, or paragraph. Common parts of speech include noun, verb, adjective, adverb, pronoun, preposition, conjunction, and interjection. The process of POS tagging is below. Preparation. After tokenization, the text is split into individual words and each word is to be tagged with its parts of speech. Lexical analysis. Each token is examined and potential part of speech are identified based on the token itself. This can be done using lexicon or dictionary that list words and their possible parts of speech. Contextual analysis. Since many words can serve as more than one part of speech, such as can, Being both a verb and a noun, the context in which the word is used must be analyzed to determine the correct part of speech. Disambiguation. Using various algorithms such as rule based, stochastic, or neutral network model, the system disambiguates words that have multiple possible parts of speech. Tagging. The system assigns the most likely part of speech to each word based on the lexical definition and the contextual analysis. My teammate Ravi will take it forward from here. Thank you.
Hello, my name is Raviteja Allu. I'll be taking the presentation from here. Some of the techniques used for POS tagging are rule-based tagging. In this, there are some handwritten rules which are already defined to a particular word with which type of part of speech it is. So, for example, if there is a word called flies, it is already defined in the rules that it is a noun. So, the word files is considered as a noun. The next POS tagging is stochastic POS tagging. In this, we consider a word and we define the word based on the prior and next words attached to that particular word. And the next approach is machine learning approach. In this, we use some models and transformers to define the parts of speech. Some of these models or transformers which are used are CRFs and RNNs. Sentiment lexicon. A lexicon is a crucial resource in rule-based sentiment analysis. It is essentially a database or collection of words or phrases in which each term is associated with a particular uh, uh, sentiment value which has a positive, negative, or a neutral connotation. This defines whether the sentence is a positive, a negative, or in a neutral state. The typical structure of a lexicon might look like this: word or a phrase, the actual terms, individual terms that will be evaluated, and the next is sentiment score. In this, a simple numerical value is assigned to each term, whether it could be a positive, negative, or a zero, which defines the sentiment score of each word individual. And the next is parts of speech. This is optional since the parts a particular word parts of speech can be changed in a different sentences. And the next is intensity, which is also optional because this in some cases a particular word gives a more strong feeling rather than the other words. For example, if we use the word excellent versus good, the intensity changes. So this is also considered as optional. How a sentiment lexicon is used in a sentence. Suppose there is a sentence. This is how we apply sentiment lexicon in general. First, we look up. When we analyze a sentence or a text, we take each tokenized word and look into the sentiment lexicon database. And the next is scoring. If the word is found in the lexicon dictionary, its sentiment score is retrieved, whether it could be +5, 0, or whatever. And the next is aggregation. In this, the scores of individual words are combined, and it is the total sentence context or sentiment is defined. And next, we find the adjustment for context. In this, the basic score may be adjusted according to the context cues identified in the text based on the negations or intensifiers. We adjust the basic scores. And the final step is resulting sentiment. By taking the aggregated score of the each sentence or phrase, by using the thresholds or other rules, we can classify whether it is a positive, negative, or neutral. Rule application. This is an important step which is used after tokenization and parts of speech. At this stage, the system applies a set of predefined rules to interpret the sentiment of the text. These rules can vary in complexity, but they essentially guide the system in evaluating and integrating the sentiment values of words and phrases by taking into account their grammatical role and context within the text. Here is an overview of how rule application works in the sentiment analysis. One way is basic rule application. This is the simplest form, which can be used in two different ways. First is word-based sentiment scores. Each word is scored against the sentiment lexicon, and a sentiment score is assigned accordingly to the particular word. And the next is score summation. The sentiment scores of individual words are added up to produce an overall sentiment score for a phrase, sentence, or text. And the next is advanced rule applications. In this, we use sophisticated systems which implement complex rules that consider several linguistic factors. In this, the first one is negation handling. Uh, In this, it changes the complete sentiment of the sentence. For instance, whenever we use words like never or not, this can flip the sentiment of the sentence. So the rules are applied to adjust to sentiment the score when a negation is detected near a sentiment based bearing word. And the next is intensifiers and diminishers. These kind of words which modify the intensity, whether it can change the intensity to high or low or neutral. Some of the examples are I am very happy. This is very a positive statement which gives a very high positive sentiment score. But if we use a sentence like I am barely happy, which reduces the positive sentiment score. And the next is conjunctions. Suppose if we use the words like but, this can change the context or contrast of the sentiment in each clause. For example, if there is a sentence called I am happy but tired, in the context I'm happy, the score is positive, but when we use but tired, then the sentiment score is reduced because but tired refers a negative score. And the last is syntactical structure. In this, the sentence might affect the sentiment analysis. For instance, adjectives before a noun might be weighted more highly than adjectives after a noun. Some of the rule application techniques that are used in sentimental analysis are heuristic based. These are handcrafted rules based on the linguistic expertise which are defined. And the next is machine learning augmented. Uh, there are some algorithms written that learn the importance and weight of the different rules from annotated data sets or the databases which are already defined. And the next is hybrid system. This is the combination of using both heuristic based and machine learning approach to optimize rule applications. Next is score assignment. Score assignment is process where each identified statement bearing a word or a phrase or a sentence contributes to the cumulative score of a piece of the text or the whole sentence. Here's how a breakdown of score sentiment generally works in sentimental analysis. Individual score contribution. Word, phrase, sentimental value. Each sentimental laden word or phrase is generally chosen based on a predefined sentiment dictionary or a database of words. Weighting. Words may receive varying importance for sentiment analysis depending on their impact of placement within a sentence, with initial words potentially weighted more highly. Aggregation of scores. First one is summation. The sentimental scores of individual words are calculated and all the words are added up and it is calculated. The overall sentence of a sentimental score is calculated. Normalization. In longer texts, scores may be normalized based on the number of words or sentence to avoid bias towards text length.
This is Sureka Hanmantkari, and here I'm going to take over the presentation. Context and modifier. So, context and modifiers are very important in understanding the sentiment of a statement correctly. So, now let us see how each element will be affecting the sentiment analysis. So, the first one comes to the negations. So, here negations are used to recognize the words like not, never, or none, and also it will be used to adjust the sentiment scores correctly. So the next one is modifiers.
So modifiers are used to modify the intensity of a sentiment which is expressed by other words, and also it is used where when the sentiment scores can be adjusted in the presence of modifiers. So the third one is conjunctions. So here the words like but or although are the signals which contrast which contrast in the sentiment within the sentence. Here the sentiment expressed after these conjunctions is often more pivotal to overall sentiment of the sentence. Here let us see an example of a sentence by the use of context and modifiers. So now the sentence is, the movie was not terribly boring but actually quite entertaining. So here the first term, not terribly boring, is a slightly positive term. So the but is a negative, and actually quite entertaining is a positive term. So the overall, by looking into this, we can say that this sentence is a positive. Sentiment score aggregation. So aggregating a sentiment score, here it will be involving summing all the scores from the individual text elements to determine the complete sentiment. So here a method that is gratefully influenced is sentiment interpretation of the text, and let us see some of the approaches. The first one is summation. Here we will be adding up all the sentiment scores of the every individual. So the second one is average. So instead of adding the scores, the system will be calculating the average sentiment by dividing the sum of all the sentiment scores by the number of scored tokens. So now it's a weighted summation. Some words may be given more weight than the others based on their importance or intensity of the sentiment they express. Now let us see the rule based adjustments. Here the rules are adjusted by the sentiment in the presence of conjunctions, negations and modifiers, as we discussed it earlier. So the next is sentence level aggregation. So here the sentiment scores will be calculated for each sentence, and it is mainly done in the longer text when combined to understand the overall sentiment. The third is hybrid approaches. Here we will be using a different kind of methods. Nonlinear combinations. Here the more complex models will use nonlinear methods which will be used to combine sentiment scores, like taking into account the context and the interplay between different parts of the text rather than treating each token or sentence in separate. So now let us see two sentences where we will be having individual scores. So the first one is, the service was good. It's a positive sentence, and the staff were very friendly. This is another positive sentence. However, the food was disappointing. So this is a negative sentence. So sentiment classification. So this is the final step in the sentiment analysis process, where here the overall sentiment score of a piece of text is categorized by using the sentiment class, like describing it's a positive, negative or a neutral. So this classification will be depending on predefined thresholds which will be determining developers of the sentiment analysis or analyzing the data. So here's how the classification typically works. First one is defining the thresholds. So thresholds are separated by the numerical boundaries from the sentiment classes. So they can be positive, negative or neutral. So interpreting the scores. So every text differentiated from the sentiment score is compared to the other thresholds to determine its sentiment class. Handling edge cases. Sometimes a sentiment score will be exactly on a threshold. So now here the rules must be there to handle these cases, like classifying them into the nearest category or assigning them to a default class, or it's like a neutral. So the next is sentiment range and granularity. So here these varies, and some systems will have a finer scale with multiple levels of positivity and negativity. Next is beyond binary or neutral classifications. So advanced systems will have additional sentiment categories like mixed text that contain both positive and negative statements, like happy, sad, angry, and so on. So post processing, the classification that include post processing steps are needed to adjust the biases, such as taking into account the overall context of the conversation or the subjectivity of the text. So now let us see the challenges. Rule based sentiment analysis will be having a predetermined set of rules and a sentiment lexicon to assess the sentiment of a piece of text. While this method can be transparent and effective for clear cut cases of sentiment expression, so it faces several challenges. So the first one comes to the sarcasm and irony. So these are forms of speech where the literal meaning is opposite to the intended meaning. So rule based systems typically look at the surface features of text and may not have the sophisticated understanding required to detect when a positive statement is meant sarcastically, and thus it will carry a negative sentiment. So the next is idioms and colloquialisms. So the phrases that have a meaning different from the interpretation of their words can confuse rule based systems. For example, break a leg. So this is a sentence wishing someone good luck, but it would not be positive if interpreted literally.
Thank you for the time and attention.